Sarah. At VARTEGA, we recycle carbon fiber, which is a strong and lightweight material similar to fiberglass that's used in aerospace, automotive, wind energy, and sporting goods. Now, as amazing as this material is, it has a couple of drawbacks. First and foremost, it's extremely expensive. In fact, aerospace-grade carbon fiber can be as much as $45 a pound. Coupled with high scrap rates that are typically as much as 30%, about 15,000 metric tons of this valuable material go to landfill or incinerated every year. That's the equivalent of approximately 652 Boeing 787s. Now, we're going to take the scrap from the manufacturer of these aerospace applications and recycle it using our patent-pending chemistry-based process. We'll then incorporate those recycled materials into automotive applications for lightweighting. That's important because for every 10% of vehicle weight reduction, we can have 6 to 7% efficiency improvement. To give you a little carbon fiber 101, carbon fiber starts out as a filament. It's wound out of spools and is woven into fabrics. When it's impregnated with plastic, it's called prepreg. These prepreg materials are formed into solid composite parts. Now, these composite parts are difficult to recycle because they don't melt down like metals. But at VARTEGA, we've developed a chemistry-based process that allows us to free the fibers from the reinforcement from the composite. By doing so, we can save 90 to 95% of the energy, which results in a 40 to 50% cost reduction over virgin carbon fiber. We've demonstrated this at lab scale at the Colorado School of Mines. We've since then scaled up to show that we can do this at commercial capacity. We've got a great team in place. I have startup experience previously. Josh is based in Washington to be close to our aerospace customers. Mark is in the Midwest to be close to our automotive clients. And Sean also has startup experience with similar hardware to what we're using. We've got a facility in Colorado, and we're planning our pilot facility, which will operate 100 tons per day. We'll take that recycled material and incorporate it into automotive applications in the Midwest. We have several other facilities we're planning as well. And that's reflected in our financials because we can build modular and scalable facilities that'll ramp up over the next several years. We've also got a couple of fundraisers that we're doing to help us do that. We're currently raising $350,000, and that'll enable us to get our material into customer prototypes, file additional intellectual property, and leverage non-dilutive funding. We've got some amazing traction. We're working on the project at the Colorado School of Mines, as I mentioned. We've got other development projects that are pending with automotive suppliers and OEMs, and we have several letters of support as we work towards our customer commitments. I want to leave you with a closing thought that we can reduce our carbon footprint by increasing our carbon fiber footprint. We can do that through lightweighting of vehicles. And in fact, the amount of greenhouse gas emissions we can save through that lightweighting effort is equivalent to about 9,000 vehicles per year. Thank you very much for your time. I'll gladly take any questions.
How far along are you in your pilots? I mean, have you actually put it to use, and is there actually gone beyond concept and beyond the testing into pilot projects?
So that's what we're working on now. We have material that we sent out to customers. There's a sporting goods client that is interested in putting in a stand-up paddleboard. They're working on that. Automotive clients as well are working to incorporate the material into intermediate materials that can then go into body panels or structural parts. So we're right on the cusp there. That's what we're working towards right now. Yeah.
That was the same question. So perhaps another question is, are you also focusing on material that would come from not a real waste source, but from dismantling source, for example, dismantling airplane?
So the end-of-life material is important for recycling, but that problem is still about 20 to 30 years out. What we're focused on right now is recycling the uncured manufacturing scrap. So it's the stuff that's coming off the floor. It's the cutting room scraps, essentially. And right now, it's just going to landfill. So it's a low energy opportunity because we can take that material and use our low energy chemistry-based process to free the fiber, whereas that end-of-life material requires a lot more energy to break that down and break it apart.
So it means that it's not yet economic?
Well, there are companies that are doing it, yeah, but the economics don't make as much sense. We've got some further development we'll do with chemistry to help to recycle those materials, but again, we've still got a couple decades, so we've got some time.
So, Andrew, what's the market size for composite material and carbon fiber? I mean, you mentioned some really big markets like automotive, and then some more niche markets like stand-up paddleboards.
Yeah, so the total carbon fiber market is somewhere around $2.1 billion. When you get that into a composite, we're talking about a market size of about $35 billion. To give you perspective, automotive is going to grow over the next 15 years, and it's forecasted to be close to a $9 billion opportunity. So certainly growing quickly. In fact, automotive's growing at about 17% right now. And even the smaller markets, the niche markets where we can get our start, like 3D printing is really exciting. That's growing rapidly.
So I get that a lot of people would like to use this material that you generate. My bigger concern is on the collection side, the quantities you can get. It seems like as they improve process and they realize how much money they're kind of throwing away, how do you avoid, your supply go away?
Yeah. So waste reduction on the waste generator side is important, right? They're going to improve their efficiency, minimize their cutting scrap. But the rate that the industry is growing at, the volumes are increasing. Even as they reduce from 30% to 10%, we still have a significant waste problem that's not going down, it is going up. So we've targeted the major waste generators where they've got a consistent supply of non-contaminated material that we can source from. So aerospace in the Pacific Northwest, certainly the automotive OEMs and suppliers in the Midwest, where they're generating easily a few hundred tons a year, which is a great consistent supply for our process.
And what's required for the infrastructure?
The infrastructure for us is actually pretty straightforward. We're diverting it before it gets into the waste stream, so taking it right from the manufacturing facilities. And we can actually co-locate our equipment on site because it's modular, so we can containerize our facilities and build out to be able to meet their growing waste generation.
Perfect.
Thank you very
so
much.
for your
Appreciate it.